Okay, let's continue with our section 5.2 notes. We have a couple planning to have 3 children in this case. First, it wants us to give the sample space for this situation. And what is a sample space? That's defined for us in the same sentence. It says, list all of the possible sequences for a family with 3 children, where B means boy and G means girl. So you aren't really a lot of times required to make your own sample space, not in this course, but in other courses you may have to. But I'm going to show you how to make one. What you'll most likely be doing is you'll be given sample spaces and used to ask those to answer questions. So what we would have to do is come up with every representation of what it could look like to have 3 children. So if they are all boys, it would look like boy, boy, boy. Or it could be boy, boy, girl. Boy, girl, boy. Girl, boy, boy. So that would be 3 boys, 2 boys, and then the other options would be maybe there's 2 girls, so maybe it's girl, girl, boy, girl, boy, girl, or boy, girl, girl, and then finally there could be 3 girls, and that would be the sample space, all possible options. So in this case there are 1, 2, 3, 4, 5, 6, 7, 8 different options in our sample space. So it says assume all outcomes are equally likely. We want to find the following probability. So here's more what you would be in charge of. We want to find the probability that the family has 2 boys. So out of the 8 total outcomes that are possible, how many of them show 2 boys? It would be this, this, this. And those are the only options that show exactly 2 boys. So there are 3 out of 8. Then we have the probability that the middle child is a girl. That's still going to be out of 8 total possible outcomes. But the middle child being a girl, if I go through and mark those, it would be those options. So 4 out of 8, which I could reduce to a half. And I'm just going to leave those as fractions. I could turn them into decimals or percentages if I needed to. I'm just going to leave them there. Okay, so it says real people often have several attributes you want to study and find relationships between. So we use the words and or to make new, more complex events. So a lot of times you're not interested in just one characteristic. You usually want to kind of say this and this, or this or this, and make these more complicated relationships. So we need to look at both the and the or and how those work. An and event is a new event created out of events A and B. And the new event consists of all of those outcomes in both A and B. Okay, then the or event is another new outcome, but this is the one that's a little bit more difficult. I think and is fairly easy to wrap your head around, but this or has a kind of particular case with it. So if you're talking about or, they could be only in event A, they could be only in event B, or in both. This is the part that usually trips people up. So when we say or in math class, and especially or in statistics class, we don't mean like the normal or that you think if I were to have a piece of chocolate in one hand and a sucker in the other hand, and I tell my son, you can have one or the other. I mean one or the other. I do not mean he can have both. But in math, both is also an option in an or. If I say you can have chocolate or a sucker, you can have both. That's also an option. So the or here is what we call the inclusive or. So that's the part you want to keep in mind when you're doing or events. And then one more definition is, what does it mean for events to be mutually exclusive? That would be events that have no outcomes at all in common, or another way to look at it is it's impossible for them to happen at the same time. Okay, these ideas lead us to our very last probability rule that we're going to cover, which is the or probability. So the probability that event A happens or event B happens, if we're trying to find the probability of A or B, how we calculate that is we do the probability of A plus the probability of B minus the probability of A and B. So again, this part right here is kind of the kicker, the part that maybe you weren't expecting. We have to subtract out that and, the overlap, so that you don't count them twice. If your events happen to be mutually exclusive, if they have no overlap, then the probability of A and B would be 0. If they can't happen at the same time, then the and would be nothing. So in that specific case only, you can simplify the formula to just the addition parts. However, I like to say, to be on the safe side, just use the original formula. If your events happen to be mutually exclusive, what happens right in that very last stage is that you'll end up subtracting 0, which is no harm. Nothing happens. You're just like, oh, I didn't have to do this part, but that's fine. But if you need to subtract something, if there's actually something there to subtract and you don't, then you're in trouble. Then your answer's not correct. So it's better safe than sorry to just always use this kind of bigger formula